Opens the door to a new generation of production engineering skills, working with advanced analytics, building predictive models in Python, designing optimization strategies that coordinate entire production networks. We're not looking at replacing engineering judgment by bringing in advanced analytics and predictive optimization, but scaling expertise. And this is exactly what we built Nextgeneer Field Optimizer to support. In oil and gas, production engineers are responsible for optimizing complex production systems. Not just a single well, but entire networks of wells connected to different facilities via different gathering lines. And these systems operate continuously 24 hours a day. And every day, production engineers need to understand how that system is behaving by reviewing well trends, interpreting production system behavior, checking how well site controllers are performing, and having a look where some wells may require an intervention or a workover. And they determine what decisions and actions need to be taken on that day at that point in time, whether it's pump speed adjustments, choke position changes, redistributing a gas lift system, or designing and scheduling intervention activities. These decisions rely on engineering judgment built from experience and expertise. But across a network of wells, coordinating optimization across entire fields becomes extremely difficult to do consistently. The challenge isn't expertise, the challenge is scaling engineering expertise. Most operators already have strong OT and digital infrastructure. Wells are connected to SCADA systems. Production engineers can remotely monitor wells and adjust operating conditions. And many well sites operate with local controllers through the RTU or PLC on site. And those controllers help regulate variables like pressure, flow, pump speed, or choke position, and they allow wells to operate safely and automatically within defined limits. But in practice, the optimization workflow at a field level still spans multiple systems. You're looking at production trends in a historian, adjusting controller settings in SCADA, and then relying on surveillance dashboards and tools to help guide where your attention should be spent and highlight where the operational issues are. And each tool is valuable, but the optimization workflow that you build in practice is still largely manual. And in production operations, the speed in which we can make decisions can matter just as much as the decision itself sometimes. So when engineers review well trends, they're usually trying to reconstruct the relationship between the system behavior and the controller settings. A change in the pump speed or a choke position. Sometimes it's an unexpected disturbance somewhere else in the network and understanding the impact it's had on the well that we're looking at that point in time. To understand what happened, engineers are mentally connecting several pieces of information. How the well responded to a change and how it was configured at the time of the change. And what other operational events have occurred across the field that might be impacting this particular well. And whether the system response matched what we expected to happen. This process is repeated manually, day after day, to try and guide individual optimization decisions. And it's the fact that we're optimizing on a well-by-well basis is where we see a scalability challenge in larger oil fields. It helps to start with the well site control system. A simple well site controller may require several parameters to be tuned. If a field has 500 wells and each well requires just 4 parameters, that's already 2,000 parameters influencing system behavior. And those parameters cannot be assessed once and set and forgotten. They must be evaluated against how the system's responding over time, against the reservoir inflow behavior changes, against the changes in lift performance, against changes in the network conditions and constraints. Which means engineers spend significant time reviewing trends and reconstructing system behavior. And that work is essential, but the time required to do it well grows quickly as the field grows. At the end of the day, production systems are inherently dynamic. Nearby wells influence each other. Network pressures will shift. Facilities do introduce constraints. Operational events occur consistently across the field. And even when a well appears stable, the surrounding system continues to evolve, which means controller settings require periodic reassessment. And like any industrial feedback control system across any industry, optimization follows, at the end of the day, a simple principle. Make an informed decision, observe the response, and then adjust accordingly. The challenge is doing this consistently across a network of wells to prevent outdated set points causing controller instability, downtime, or deferred production. Many operators turn to exception-based surveillance. How do we help perform production surveillance by exception and prioritize different wells based on different alerts that help us identify when a well might be outside of its operating conditions or expectations? And This is extremely useful, but exception-based surveillance on its own is usually quite reactive. It tells us when something's already happened. It rarely helps engineers evaluate how operational conditions should evolve across the field, and once reactive issues are resolved, how do we get on the front foot here and make proactive decisions? Such that if we can make some more proactive decisions today, we can have a net reduction in the amount of work needed by seeing less reactive decisions tomorrow. One useful way to approach this challenge is through decision analysis. Decision analysis means clearly defining what decisions can be made by production engineers on any given day, what objectives are we trying to achieve at a field level, what constraints exist across the entire integrated production network, and what alternatives should be evaluated before we act on a decision. And when we apply this thinking to production engineering, look at field optimization, it becomes clear that field optimization is not a single decision on a single day. It's a continuous sequence of decisions over time. And those decisions interact across wells, lift systems, and gathering networks, which means that optimization is fundamentally a dynamic optimization problem. Now, let's imagine a different way of operating the field. Instead of engineers manually reviewing hundreds of trends, analytical systems continuously analyze behavior across wells, lift systems, and surface networks. Production engineers define the events and anomalies they normally look for, but ahead of time, and then we set up algorithms to monitor for these events and anomalies across the field. Then we're able to establish predictive models to evaluate how we expect the system to respond to change. We predict those events and anomalies ahead of time, based on different decisions we could make. And with this shift, engineers can move from analysing wells individually to scaling their expertise across the field, from one well at a time to potentially thousands, from one day of analysis to ongoing optimisation across the year following the same systematic evaluation at scale. And when that happens, the role of the production engineer begins to evolve as well. Instead of spending hours reviewing trends, engineers begin defining the events, constraints, and optimization strategies that govern their field. Their expertise becomes embedded into the optimization system itself, and that opens the door to a new generation of production engineering skills. Working with advanced analytics, building predictive models in Python, designing optimization strategies that coordinate entire production networks. We're not looking at replacing engineering judgment by bringing in advanced analytics and predictive optimization, but scaling expertise. And this is exactly what we built NextGeneer Field Optimizer to support. It enables production engineers to define the events and anomalies they want to encode with advanced analytics and build predictive models that help detect and forecast these events and anomalies. The platform then offers a predictive controller framework that can help you evaluate potential set point adjustments against field level objectives and constraints. The platform also provides integrated workflow management and analysis tools so that every opportunity can be efficiently reviewed and acted on. And the value of every action can also be traced and managed over time. This also creates the ability for engineers to automate small incremental set point changes, to take the advisory support from the system, configure it to their needs, and see those changes applied automatically. To illustrate this, let's imagine a field with 500 wells. And let's say 100 wells have been identified as potential candidates for small set point adjustments. Those changes can be evaluated and applied systematically before the production engineering workday even begins. And engineers can configure and oversee the process day to day. In practice, perhaps 30% of those changes require a short review after the adjustment, and maybe 10 wells require deeper engineering investigation. So instead of reviewing and making 100 changes using exception-based surveillance, engineers are focusing their attention on just a handful of wells, reviewing and correcting any false responses. And that's what decision scalability begins to look like in practice. So the key questions to take away are, have you actually considered how scalable your field surveillance and optimization workflows are? How much engineering time is spent interpreting well behavior instead of evaluating strategic field level decisions? And what change would you see if production engineers could scale their expertise across their entire field? Because solving the decision scalability challenge may be one of the biggest opportunities in modern production engineering. To explore this further, we're offering a 12-week field optimization study to upstream operators this year, from May this year. So if that sounds relevant to your field, you can find more details on our website via the link in the description. Next video, we will delve deeper into what this actually looks like in practice to build scalable surveillance and optimization workflows in production engineering.